So I would be. But we're using your seat right up.
That's
Exactly what he said. Get him a seat and take out a pencil before we finish, like saying the wording.
That's not how it is.
It doesn't make sense to me. Like it's so arbitrary.
Hey, arbitrary. It's like the least. Yes.
Is baseball
Pardon?
Is baseball
I don't think so. That's strange.
Yeah, it is last six. It's really good.
Ronan's so close. So close. I mean, Julie was closer, but you were still close. Good afternoon. So the first problem is, of course, the date to make sure that your partner knows how to do it. And then the second one is how many words, meaningless or meaningful or not, can you make out of these crazy letters?
Oh.
You okay? You made it. Glad you're here. Yeah, thank you.
Okay, so we've got 5 letters. So for letters, let me see if I three repetitions. A, so 3 factorial, 2 factorial.
They are.
Doing them all basic.
That is gonna be great.
Yeah, it's like the factorial, like the.
You got done?
Yeah.
Yeah. It's just. There you go.
Aiden, what's happening here? What is all this about?
It's no, it's the other one.
Okay.
Combination.
Okay.
Combination, so it's 23 factorial over, and then it's gonna be 23 minus 22, so it's gonna be 1 factorial times 22 factorial, which just simplifies down to 23.
Are we good? Thank you very much. We have briefly discuss with the neighbor, what's the difference between a permutation and a combination?
What happened last 45 minutes?
Okay, so difference between permutation and combination? What's that, Max? Are we good? Permutation, the order matters. Combination, it doesn't. Cool. So this one, I need some help. How many words meaningful or not? I think maybe none are meaningful. Josephine, how many can we make from here?
Like 10.
How? How do you know? Did you just make the list? Did you write them out, or how'd you do it?
Yeah, so we have 5 total letters, so it's gonna be 5 factorial, and then we have 3 repetitions of A and 2 repetitions of B. So then you get, put over 3 factorial, 2 factorial, and then you can cancel out the 3 factorial to just make it 5 times 4 divided by 2. 5 times 4 is 20, divided by 2, 10.
Nice. Are we good?
Yeah.
Nice. So you actually did the 5 times 4 divide. You did the 20. I don't even want to work that hard. I would just do 4 divided by 2, but I think it's the same. Okay, so either way we get to 10. Is there another way to express, and thank you very much. Well, not is there another way? I'd like for you to discuss with your neighbor, what's another way to express this quantity right here? Without using like 5 times 4 times 3, what's another way to express that?
Find another way to, wait, like the total quantity or just the loss?
The whole expression. Whole expression.
Yeah.
Yeah. Yeah, yeah. Yeah. Solve, I guess.
Oh, yeah, would be,
Do like 5 factorial over
because like when you have.
five factorial, 2 factorial, and then you're putting that in
So
the same
that is-
form as combinations.
Okay, so what's another way to express this? You know what I'm referring to? Hey, Aiden,
Like the front, 5.
is it true that these are equivalent? Or this?
Why is that?
So of the five cases, 2 are B's or 3 are A, the way it works. And do we care about the order? Alright, but these are all the same thing. So how many of them are there? Or 10 of them, they're all the same kind of word that's being jumbled. So that's where that 10 comes from. The order doesn't matter. But there are 10 of them that we kind of put together. Okay, so that's introduction today.
Today is our last section, isn't it? In this unit. Is this the last unit? No, this is not the last unit. It is what's the next to last? What's that word? Penultimate. It's the penultimate unit. This unit is penultimate unit. So, yeah, man, time sure does fly. That means next time I see you, we're gonna have a test? Review, yeah, and then after that, the test on Tuesday. I understand there's a big time crunch for a lot of students this week. Is this true? Like, we got a ton of things to do, so probably best that there's no test this week. It just worked out. Hopefully.
Next week is.
Oh, it's worse next week? 7? Woo. Lucky, it's gonna be like a roller coaster for you. Sorry about that. You want to just take the test this week? No. No, okay. Okay.
You have multiple tests in
Anyway, I understand that the life of Harvard Westlake student is not slow paced, so I appreciate everything that you're going through, and I appreciate the time you give this class. And let's focus and finish this off. You'll notice that this unit has generally been chapter 12. Everything that we did at first was chapter 12, and then we jumped briefly into chapter 13 for the counting permutations and combinations. Now we're back into chapter 12. This is 12.5, the binomial theorem. Okay, so I think you're all aware when you multiply a plus b quantity squared, you know the result. Oh, yeah. But before this, by the very first time you multiply that out, you got a squared plus ab plus b squared. If you can combine these because they're like time. Actually, so the letters to get this.
Binomial theorem says, well, raise a binomial before this square, and you could cube them into the 4th power, and here they are. You could also raise them to lower powers, the 1st power to the 0th power. So we're looking for a pattern here. Now, some of you have already seen this, so please don't call it any sort of answers. Have you seen this in another class? It's fresh right here. Last year, now it's right here. Some people, I would say this. Those of you who got it last year, did you see this? Definitely not. This is a pretty strong outfit. This one, have you seen? You could get this, you can verify if you wanted to by doing some major distributive property, but I would. There's the field power here, so it's the power. So let's take a look at the pattern that we see here with our
Binomial expansion. So if we take away all those A's and the B's, we're left with just coefficients, right, Al? Just left the coefficients like that. First one is just a 1. We do know that A plus B to the 0 power is 1. So we have this 1, 1. I'm just taking away all the A and the B. So for row 2, we are already familiar with the 1, 2, and 1. Row 3, looking up here, it's 1, 3, 3, 1. And for those of you who already know, there's a reason we're putting these together like a Christmas tree kind of shape. Go ahead and finish up to row 6. Okay, so on the count of 3, if you know what this is called, I'd like to hear what the name is. 1, 2, 3. Yay, Pascal's triangle. And I do want you to discuss the patterns that you see here. What do you see in these numbers?
So you add the two numbers above it.
Let's go back. Let's go back.
Okay, so the pattern that you see. Did you all see what Baron was talking about? Like this 15 right here could be generated from the 10 to the 5 above them. And that goes for everything, doesn't it? The some of the two numbers above result in the number that's below in the middle. So this 20 came from the 10 and the 10. And yes, that is definitely true of all Pascal's triangle. Of course, the first and last numbers, it's an easy pattern there. Ones. What other patterns do we see? So it's repeating. Oh, it's like symmetric, isn't there's like a line of symmetry in there. Yeah. Anything else?
On the third way, going back,
So you're looking at these. So plus 2, plus 3, plus 4, plus 5. Okay, nice. Anything else?
facing this 3, 6, 10. What's that? There's got to be something. There's got to be something. I don't know what it is. Maybe some sort of quadratic arrangement. I think one of these take two numbers and add them together. Other nice ones to see are if you take the sum
Of each row. one at a time. Go ahead and take the sum of each row.
It results in the powers of two, right? Right, two cubed. That's the same as that row three. Other things, my favorite is has to do with 11. You know this one? Yeah, like you know what 11 squared is? See it? Do you see it? Is it 11? You know what 11 cubed is? Yes. Yes. How about 11 to the fourth power? Any idea? Is this true? Is 11 to the fourth power really 14,641? It is. Now this does stop working with the fifth.
Yeah.
Because really this is saying 1 10,000, right? And this is 4,000, and then this is 600, and this is 40, and then this is just a 1. So if I were to do the same thing with the other one, I'd have to start with, and this is just 1 plus 50, there's like 51. And then this 10 kind of, this is 1000. So you have to start carrying things over. You have to carry the 1 over here, it becomes an 11, it's now 11,000. It becomes a little bit complicated, but we could do this. I believe if we start from the right, 1 5 0, that we have that 11 6 1. I think that would be 11 to the fifth power. I think. I'm not sure, but yeah, it's definitely not as pretty once you start getting double digits. So, how about 11 to the first power? Does it work there? Check it for me. Yeah, 11 to the 0 power. I think it works there. Mathematicians have gotten into row -1, -2. Which is kind of interesting. Like, how do you even do that?
Is it like a, is it like going
It's like,
that way?
yeah, it's like some sort of inverted cone. Pascal's hourglass, yeah. But it becomes purely abstract at that point. Like it just is weird. I don't even remember. It was kind of, well, it would be if we have to go back here, right? A plus B to the negative first power. It comes from here. So we know that's 1 over A plus B, but then they were able to separate that somehow. And I don't remember how they did it. But if you're interested, the world is your oyster on the internet. It's out of the scope of this class anyway. We just started 0 for this. But yeah, that's a whole other rabbit hole. Okay, so just cool stuff about Pascal's triangle. And there's more, but we'll stop with that. So given row 6, row 7 is quite easily done, is it not? Go ahead, write it to make sure your neighbor got the same thing you did, or just check that yours matches mine. Now expand x plus y to the 7th. Could you already do that? What's that? Apply the coefficients, but we didn't talk about the rest of the terms. Right, the rest of the terms, like if you start with a to the 6th, then the a's kind of go downwards, whereas the b's kind of come up. So we're going to start with this one with 1x to the 7th plus, I'll let you finish.
I want to hear. You ready to discuss? We discuss before I call someone. Ayla, what'd you do? Excellent 6. Wow. If one of them is next to the fourth,
Does it make sense that the next one is y cubed? Because we're expanding to 7th power, so those two should add to that. Okay, so keep on going. You're doing great. Okay, you could do it. Nice. But why did the 7? Are we good with this? Please do not use distributive property if I ask you to expand this on a test or a quiz. Please. You may, but you need time for other problems. Thank you very much. Okay, so let's talk about this. We could find all the terms of expansion by actually multiplying the factors, and I've done this for you. If we did not reorder the factors or use exponents for ease of addition, it would look like this. I hope it makes sense that one of the terms is A. Next one is AAB, there's also an AABA, these four are put together. Because they're kind of the same thing. And then this one, there's like this, and this, is that right? Oh, and one more. Oh, and this one. And then these are the same. And then this one last one. Yes, if we didn't kind of reorder A and the B. Okay, and of course we can put these together because the order doesn't matter if it's multiplication. So what we're dealing with is all of the numbers in the Pascal's triangle are just a combination. Like this is a combination of out of these four, how many ways can 3 of them be in, or choose 3? Out of these four, how many ways could there be 2 in? Just 1, 2, 3, 4. Go for it. Out of 4, 5. So how many different ways can we arrange that? So it works. And it's a combination because we don't care about it. The order doesn't matter to them all together. So this is connecting Pascal's triangle to combinations. So let's see. Could you go ahead and calculate all these 5 values?
for zero. Before. One. Okay. Let's move on. Okay, so this is written in a fairly complicated way, but it's just saying.
Remember, expanding x plus a to the nth power. First one is gonna be x to the nth, we know that first one is gonna be one, that we choose zero. And choose one, a, and the x's. The exponent for the x's are going down, while the exponent for the a's are going up. So use the binomial theorem to expand x plus 2 to the fifth power. When using the binomial theorem, you have two choices. You could either use combinations or you could use Pascal's triangle. It's your choice. So for the fifth, I've already memorized 1, 4, 6, 4, 1. I'll probably just use x to the fifth plus 5x to the fourth times 2. Continue. Asking someone to share with us the rest of the expansion. So check the neighbor once you're done. I want unsimplified and simplified.
Max, finish. Can you give us the unsimplified version of what you did first, please? So, hold on. I said 5x to the third? Where the 5? Oh, okay. Thanks. Third time.
Times 2 squared, okay.
Yeah. Yeah, okay.
Get it? You're on the right track? If you're working away and your neighbor's confused, I need you to do your job and help them. So check in, make sure everything's going well. Excuse me.
Oh, yeah. Oh, it's too wide.
We call on someone in about 15 seconds. Okay, ready or not, I'd like to see what you got. Terry, I have a question for you. What do you do with this negative? What you do about that? That's subtraction.
Well, I didn't know y plus minus.
2y plus like a -3. Does that seem like a pretty good, or plus negative? That seems like a pretty good solution. Thanks. Okay, Terry, help us out. Expand this, please.
Y before power.
Okay,
4y cubed times 33.
for just y cube, like this? Maybe 2y cube. Okay,
Y cubed times 33.
okay,
Plus 6 times 2y squared times 33.
okay.
Plus 4y, or 4y. Times 33. Plus 2 times 33.
Oh, sorry. It's like that. So is there, did I hear a 2 or something like that? Did you say that?
Yeah.
Why is there a 2 in front of the -3? I think we have the 1 in the front, we have the 1 in the back, we have the 1, 4, 6, 4, 1. You got those coefficients? Perfect. There was a ghost too, but sometimes that happens. It's okay. Be careful. Terry, thank you so much. Do we need to expand this or are you okay already? Of course, when you expand, it's no surprise, it's going to alternate plus, minus, plus, minus. So you can either bring that negative along for the right as Terry did, or you could just say, oh, this is a minus. So I know I'm going to start with positive, and from there, kind of just adjust minus, plus, minus, plus, whatever you like. Just make sure that's right in the end. We good? What's that? I would expect it to be multiplied out. Yes. So I would expect like 16y. I want to see what is this? 8 times. There will be a calculator. You will be allowed to use calculators on the test. At least part of it. At least part of it. We'll see. Who knows what secrets lurk beneath? Okay, moving on. Okay, here we go. Use the binomial theorem to find the indicated coefficient or term. A Pascal's triangle is great, but it becomes a little bit cumbersome. Does that, you see what I'm saying? The 10th power, you have to keep working down it. And you can imagine me giving you to the 20th power, to the 50th power, something like that. You could try to do Pascal's triangle, but I recommend just going directly to what you're looking for. Like this one's asking for the coefficient of x cubed. I give you a minute to discuss. How would you get just that coefficient? Okay. So it just talks about the coefficient of x cubed. Is this the first term? You know, the first term would be x to the 10th, right? Is it the second term? It's not the second term. That would be something x to the 9th. So we go directly to the term we want, which we know is going to be x cubed. The other portion, well, there are two parts. Does it make sense that there are two other parts?
Yeah.
There is a coefficient and there's that second term. The second one is going to be a -3 to the, are you sure it's 7? How do you know? Because we know that 3 plus 7 is 10, and they all have to add up to 10. But how about in that, the coefficient? How do we determine that? Yes.
What is certain with that the other thing, or you like, n over n minus.
Yeah. It's 10 choose either 3 or 7. I can do the small one, but it's the exact same thing. Very nice. Thank you. Good connection.
So once you crunch all these numbers, you barely get the coefficient.
Oh, yes. Have you figured out how to use the combination button on your calculator? There's a, well, not combination button, there's a combination function. Please check with your neighbor to see if you've found the combination area. You don't have your calculator, just make sure you see it with your neighbor. Share with your neighbor, make sure they know. Yeah, you put an exclamation first. Switch it. Oh. But still, there's a combination function. You should be able to put in there. In a minute. So combination, where do you find it? Math and then which? Probability, either there or where else can you find combinations? There's another place in the hidden menus. Specifically, alpha, F. Does anyone see it? Alpha, Is it F3? I think it's alpha F2, isn't it? Is it alpha F2? Do you see a combination there and permutation? So there are different ways to do it. You don't have to type in the factorials in your calculator. You don't have to do it by hand. I do like you to be able to do it by hand before you do it in your calculator, but you should be able to use both now. Okay, what does this work out to be? What is the coefficient? I think it's negative something. A lot, yeah. Good point. Negative 262,440. Did everyone else get that? Cool. Thank you. I'm gonna let you do B, but go ahead and do B. Then we'll do C together. I'll call someone for B in just a moment. We'll do C together. Yeah, thinking about C if you want. Okay, here we go. I'd like to hear from Lyra, please, for B. How'd you do it? That makes sense. Yeah, why is it 6? I think that's where you get it. Okay, so and once you have this, then you get, what was your answer? Plus 112? I think we might be done at that point. Oh, times 4? Oh, times 4, I see. Is it? Oh, so this so far is this?
Yeah.
Oh, so it's gonna be 80,000 something?
Yeah.
80,000. Anyone 648? Right, we gotta put all those numbers together. So you had it right there. Are we good? Okay. The next one is interesting. For all these, there are 3 parts. Do you want me to talk first, or do you want to struggle a little bit? I'll give you like 30, 40 seconds to think about it, because there's something strange going on here.
Oh, wait, oh, wait. Now I see it, now I see it, now. Okay. Oh, oh, I see it. No, I know.
No guessing in a second. Don't just guess.
Struggle with it for a little bit, or do you want me to just tell you how to do it? The answer to that question should always be, I'd like to struggle with it for a minute. All right, don't you think? In a math class, don't you think? I mean, that's how it works on a test. It's all you. You've got to think before you're given stuff, right? I'm here as a guide, so the appropriate answer is yes. I'd like to think about this. Give me a chance, because you got a brain. You can use it. Now, a lot of times that brain leads to false answers. Like you might think it's cubed to get that x to the 6th, which makes sense. I'm gonna leave that negative off of here. I'm just gonna do this. The problem is that you have a 1 over x to the, if this is cubed, then this would have to be to the 6th power, and suddenly that 6 that we had is now gone completely, isn't it? So how do we find the term that does have x to the 6th? Does everything what I have here make sense, and say how? Because if I multiply this out, we get x to the 6th times 1 over x to the 6th. The x's go away. So if we're looking for the coefficient of x to the 6th term, there is no x anymore in here. So how do you find it without just saying, well, let me try 5, let me try 4, and hope for the best? That'll work eventually, but how about you use a little bit of algebra? I'm going to call this m. Now, if that's m, then the other one is going to be n. 9 minus m. But how is this going to be like? I'll give you a moment to think about it.
Oh, well, I'm gonna get a sticky, like, I have negative 1. I'm x to the negative 9 minus 1.
I like what I'm hearing over here. I like this. Okay. How's this gonna be helpful? Or is it? How's it helpful? Josephine, help me out.
Well, you can convert everything to the base x.
Okay,
So you would take the, like, x first, then you just give the x to the two m.
okay.
And, one over x is the same as x to the negative one, so then that's gonna be x to the negative nine minus m. Equals x to the six.
Equals, does that make sense? Set that equal to x to the sixth? Why x to the sixth?
Solving for the, like, the six, what, for x, we're solving for x to the six.
Yeah, we want it to be that. Exactly. So where does this, what do you do with this now?
And then, because they're all have the same base, you can cancel out the x's.
So this is x to the, so this is,
Two m times, m minus nine.
oh, that was nice. And then what do we do with those exponents on the left?
Add them.
Add them. That's where we get that 3m minus 9 equals 6, I believe. And therefore m equals 5. All right, so that's called letting algebra do the work. Josephine, thank you. Nicely done. So if this is 5, that means the other one is? Or is this going to work? Is this really going to give us x to the 6? You can see quite clearly that it does. And in the combination, the top number is 9. The bottom is either 4 or 5. Either one of those. I'll do 5. And I left that negative off on purpose because it gets in the way, so I'll put it back in there. It does belong there. I just cared about the x's. Okay, so you can work that out and then work on D. Did you get the coefficient? For C, did you get the coefficient? I think it's 95. You're working on D now? You finished C? Ronan, what did you get for C? Yeah. Did you get that one?
Okay, so, I'll do.
Is that it, 126? Okay, thank you. Yeah.
First one half, so x to the 1/2 m, plus, x to the 1/2 b minus m. And the thing in front of that is one of the perfect 9, like where we did 9. I guess I could, yeah. I think we're just gonna do this. No. Yeah. I think it's solving for maybe the, like, what's the.
Did you get it?
So don't have that one, but it's not, there's nothing else that's like, the X, that, like, the X.
Anyone? Anyone? Yeah, of course.
Later is gonna happen. Like when you're solving for, like, what term is X? So if you ignore the, because it doesn't have an extra intent, like, attached directly to it. So it's not gonna affect whether or not it's X squared or X squared. I know. Oh. Yeah, oh, that's gonna be, I feel like for, I don't know. So I. Oh, no, sorry, oh, wait, I see what it is. I, because then you said, I'm looking for. No, I don't. Oh, what? Well, no, I know. I did not know. But I did. Right? Okay, there we go.
I got 6. Yeah, I got.
Yeah, I got.
Yeah.
So then I. Something's divide the whole thing.
Oh my God.
Like if we just divide this, like, okay, so if we then we'll find it. Okay, so it's, you're just right. The next. Oh, half and that one is gonna be 9 and. The negative, no.
Are we ready?
So the 9 times.
20 seconds. Okay, I'd like to hear from Ronan. Could you tell us how you did this, please?
I did by separating it into, root x to the y.
Root x to the y, okay.
Or, then I did, video the root x. To the y.
8 minus y, okay. 8.
With the root x, I did x to the 1.5 y.
Nice. Let's say 1/2 y.
The other one,
Did forget about it. Okay.
x, or I did 1/2. And then
So far, so good? Equal to, oh, it's equal to x squared. Okay. Nice. Equals to, okay. Any questions about what he's done so far? Does it make sense that for the side work, he could just ignore the 3? It doesn't, we don't care about that. That's part of the what? 3 is part of the coefficient. We don't care about that. We're wondering about which term it is. Nice. Okay, so Ronan, go ahead and finish up what you have here. So I think what we're saying, this is now 6 and this is 2. Okay. H choose what? Either H choose 2 or H choose 6. It's gonna be one of those 2 numbers. It doesn't matter. So H choose 2. And then et cetera, et cetera. I think if we work this out, it's gonna be x to the second power, is that right? And coefficient. The 252? That's with the 9, of course. Okay. Cool. Okay. Ronan, thank you for your help. Any questions? Do you like binomial theorem? Do you like binomial theorem? No? A little bit? Kind of interesting? No? I think it's pretty cool personally, but that's why I'm here. Okay, you have some time to stretch if you need to, or work on your assignment. Or if you need to get some water, now's a good time to do that. Here, let me-